because your framework sucks too. And that means Zen Framework, Symfony, even Cake, Kohana, and pretty much all other major frameworks major frameworks out there. Why? Except for the fact that we like to be provocative. Well, all frameworks suck because they contain stuff that you're never going to use. There are lines of code and frameworks that you will never end up executing in your application. There's inherent complexity overhead. It's many layers of abstraction that are built into the framework to allow flexibility across different projects, different adapters, different implementations. And the obvious one of you didn't write it. Programmers tend to have an aversion to any kind of code that they didn't write in the first place.
Programmers also like to feel productive, and writing your own code feels a lot more productive than learning someone else's.
And my favorite reason would have to be Martin Fowler. So his name is the biggest on this book, which is why I say that it's his fault. But we're not saying design patterns are bad. I mean, Lithium uses a great deal of what you would typically call design patterns. Completely the opposite.
So the thing about patterns in that book in particular is that Martin Fowler spends as much time disclaiming patterns and explaining when not to use them as he does when to use them. And the other problem with patterns, particularly in the context of PHP, is that a lot of patterns we see commonly in software design, particularly in patterns of enterprise application architecture, a lot of those exist to solve problems inherent in other languages like Java, which simply don't exist in PHP. So Lithium implements a bunch of design patterns, and to great effect, and we'll take a look at some of those in a little bit. But the problem, a lot of patterns that people end up using only treat the symptoms of the design issue, the underlying design issue that we're trying to solve, rather than the cause.
So we'll look at some examples. Typical ones that you'll see in most general application frameworks out there. One big one, object dependencies. So the general principle of you should separate how you configure something from how you use it. So we'll take a look at some code that is rather familiar to some of us from Cake PHP itself. So you probably can't see too much of this right here, but this is actually an excerpt from I don't know, where is this from? It's from controller initialization.
The dispatcher, I think.
Oh, dispatcher initialization. That makes more sense. And there's parts in here that kind of suck. So right here we're calling a static method on basically a static class, so router prefixes. And that's a problem. And down here in this part we're actually doing a comparison on a basically global state, which is the configuration debug level. Then based on the value of that, we're importing another class and then calling a static method on that newly imported class.
So this is bad for a couple of reasons, and primarily is you can't ever swap out that class or method, so it's impossible to test the dispatcher class in isolation because it's always dependent on this other state.
Yeah, in this particular example, it's impossible to test it when you have a debug level of greater than 0 because at all those times you're going to be loading up the debugger as well. So configuration is something that everyone likes to do a bit differently. Sometimes you configure things differently in the same framework. Sometimes you'll configure things differently within the same class. And so this is a real problem when, especially as people who use a framework, one of the reasons that people like frameworks like Cake or Lithium or even Symfony is that there's a lot of stuff based on conventions, and you just know where things are because it's a pattern that gets repeated everywhere. So we've got stuff here coming out of Cake PHP, basically an excerpt of how you would use the email class and how you would want to send emails in a loop. It sucks a lot because you're actually configuring it in two different ways. You're setting object properties and then you're having to reset those same object properties in a loop, when really most of the rest of the framework you configure using arrays and passing those arrays to the object. Whereas in this case, you're setting different object properties. So this stems from the fact that a lot of, like in a lot of open source projects, various parts of the framework are written by different people, and because there was no reason that people were trying to keep things consistent, that it just ended up like this.
Or no overarching conceptual integrity, if you will.
Yes, as a great man that we just saw on Monday say, Fred Brooks. So another big problem is dependency injection, which is a great idea. Dependency injection is actually one of the cornerstones of writing testable code. But there are some problems with it when people try and take it to extremes. So we'll take a look at user class that we've got right here, a typical use case of dependency injection. We want to separate out the concerns from the user class and the arbitrary storage mechanism that we're going to use for session storage on this user, let's say. So typical pattern where we pass in the object that we wish to use into a constructor, and then we use that internally in the object in the method definitions. But we need to abstract that out, of course, because we're a framework and we like to abstract as much as we possibly can. So we're going to wrap that up with a dependency injection container. So we add a bit more code. Now I know this doesn't look as good as, it doesn't look very good over Ustream, but so we wrap it up with your typical dependency injection container. But of course, we need to abstract the dependency injection container again. So we're going to create a service container, yet another web application or just general pattern. Like, okay, this is starting to get a little bit better. We've abstracted it a lot. We can configure things. We have our dependency injection container, which is abstracted away too. We don't interact with it directly. But no, now we obviously want to abstract out the service container. So we'll use a builder pattern to configure the services contained in the service container. And at this point, we've basically invented our own microsyntax, another language on top of a language, which kind of makes it a bit difficult to read, but we're good with abstractions. And of course, we're going to have the whole thing configured with XML files, because we need a little bit of enterprise in there. So we've got dependency injection, managed by a service container, parameterized with XML data. We configure it all with a builder, and this is all to fix one problem. So I'm sure a lot of people can see that this is perhaps not ideal.
So a lot of the patterns that we just looked at being implemented were actually originally implemented in Java to solve deficiencies in the language that didn't allow you to do things like dependency injection as simply as you can in PHP. And especially within languages that have first-class functions like PHP as of version 5.3, that gets rid of many, many other Java-esque design patterns like command and visitor, which just become completely irrelevant. So if you want to learn a little bit more about how design patterns can go amok, try this sometime. Google hammer factory and check out the first result if you have a few minutes to read an interesting essay. So, now we've come to the second part, wherein we discuss why everything you know is wrong. So, this is a picture of Galileo being blasphemous, and we are going to be equivalently blasphemous talking about object-oriented design. And we'll start with dependency injection, which I consider kind of a band-aid in a lot of cases. Again, it's still a legitimate pattern to use in a lot of cases, but it's also overused where other designs are much more appropriate. So here's the basic pattern or problem that dependency injection tries to solve. Here we have a logger class that's being directly instantiated inside of another class in order to perform some functionality that's really not directly related to the domain of the first class at all. And not only that, but we can't swap that class out for another one or change the behavior in any way. So the problem that dependency injection does not solve, however, is yes, okay, you can swap that out for a different logger, let's say, but even in this case, you're still calling the same method on the logger class. So we're fixing the problem of static dependencies, but we're not doing anything about the fact that the relationship between those two classes is still exactly the same. The same method is being called on whatever class you end up injecting. And if you wanted to add some new functionality, say caching, for example, you would have to add some other dependency injection code and some other code to interact with the caching class. So you end up with more boilerplate code per thing that you want to attach. So for every cross-cutting concern, there ends up being more. So here's an example of dependency injection in Lithium. Here we're injecting a socket class to do an HTTP request for this HTTP service class that wraps web services. So here we're saying dependency injection is okay, because in this case, where we're working with a class that interacts with a web service, we actually need something to make HTTP calls. It's relevant to the domain. So the baseline principle is that the level of coupling between different classes should be in proportion to the relevance of the domain that you're working in. So posts and comments would be examples of domain classes that are directly related to one another. So it's okay for those to have tightly coupled dependencies. But things like logging and caching and so forth are completely unrelated to any other domain. They're just utilitarian stuff. So they really shouldn't be coupled to any classes at all. Another problem that OOP doesn't really address is that of state. And what I mean by that is this. If this kind of thing right here, where we're setting some global state, is evil, then this, where we're setting some local object state, is the Diet Coke of evil. So why is that? Well, here's a quick example. So we have another example of a service class, and this one is completely fictitious, but suppose we have a timeout property that you can see at the top here. And then within the body of this send method, we're calling another method called prepare. Now, that prepare method exists within the scope of that class, so it can see the timeout property and modify it however it wants to, and we have no way of knowing. That method could be doing anything, modifying any other state in the class, and we have no idea what that state is by the time we actually get down to the bottom where we have to use those values. So the underlying principle here is that mutable state, or state that can be changed, like properties, objects, any piece of information within the system that's changeable, is the main source of software logic bugs. And computers are really good at tracking this kind of dynamic process flow where one method chains off to the next. Humans really aren't.
So one of the fundamental things about object-oriented programming is a lot of times you don't have to think about state. And mutable state in objects is one of those things that is most of the time the cause of many software defects. If you can think back to different bugs that you've tried to solve, and some of the most difficult ones that have been to track down, I'm willing to bet that a lot of them started out with the fact that you were calling some method that changed the value of some variable somewhere on some object that you didn't know about, and thus sends you down this long stack trace of trying to figure out what the heck happened. So just because object-oriented design is relatively easy to model things doesn't mean it's the right choice in every single situation.
So, design patterns. Design patterns really, people feel like will solve all of their problems if they just find the right one. And everyone has their favorites. Well, the problem is, design patterns aren't a golden hammer. As we mentioned previously, there are just as many cases where you don't want to use a certain design pattern as cases where there are. So each pattern is only useful in a very, very particular context, and you have to understand the trade-offs in order to use it effectively. And as we saw earlier with layering many design patterns on top of one another, that's usually indicative of a poor underlying design. So you need to really understand what it is that you're trying to design before layering a bunch of patterns. So just remember, knowing a set of tools does not mean you can build a house. So here's where we try to suck less.
So we built Lithium with the general idea that if you're going to be using a framework, it should try and suck as little as possible. Because as we discussed before, all frameworks do suck, but we can do a lot of things to try and minimize the amount of pain. And we go about it by trying to find solutions to problems that are appropriate to the domain and appropriate to the problem at hand without going into 4 or 5 different levels of abstraction. One of the tools that we utilize in the framework quite heavily, at least within the framework, and is available in user space, is aspect-oriented design. The fundamental reason that this came about was because people are trying to separate their concerns. So the typical example is that you've got a certain class, let's say a model, where you're doing a find, and you wish to cache the results of those finds. You wish to cache them if you wish to hit the cache to see if it is there, return it from the cache if it does, and if not, you want to do a read through, find it in the data, find the item in your persistent data store, and then cache that result so the next request won't actually have to hit your database. Now the problem with that is that you're coupling your cache class to the implementation of your model at the time. When it really doesn't need to be there. Cache should not have to know about the model, and the model should not have to know about the cache. So the principle being that your domain classes shouldn't care about your cross-cutting concerns. And cross-cutting concerns are, like I given the first example of, caching, logging, even access control can be done away with in this kind of pattern. And another tool that we're big fans of is functional programming, which really is only possible when you have functions as first-class citizens, meaning that functions can take other functions as their argument, and functions can return functions, which gives you a lot of really interesting things. And one of the fundamental concepts that is central to pure functional programming is referential transparency, which means that if I have a method call and I can replace that method call with the results of that method, I have it, and the application will behave in the same way, then that method is referentially transparent, meaning that that method invocation did not trigger some mutable state somewhere else in my application. It didn't update some variable somewhere in either global state or object local state. And of course, this all ties into the whole concept of functional purity.
So another way to think about referential transparency is that a function which is referentially transparent doesn't modify anything outside of its own scope. So that means no $this, no date, which is a form of global state, and no $_ global variables. This also means other things like no variables taken by reference, since that variable exists beyond the scope of the function, and modifying it makes the function not referentially transparent.
So that's not to say that we don't do these things. I mean, it's PHP. We do have to deal with global state. We do have to use this for local object context. There are instances where you do need to take the date, and we do have to parse data from global variables. However, being conscious of how best to separate methods that are referentially transparent and that do not depend on state, and those that do, is a great aid in trying to design a system that is least intrusive and as well behaved as possible.
Another thing to note is that Lithium uses a lot of static classes, and many people have heard that static classes are hard to test, static classes and methods. And this is a concept that we use heavily in static classes to ensure that that's not the case. because the only problem with static classes is that they're either not referentially transparent, or, as we saw before, can't be swapped out with other dependencies for testing and that kind of thing. So, whereas PHP 5.3 does allow you to make what are called dynamic static calls. So using those two concepts, we're able to make statics very easy to test, and this is one of the important concepts around that. Now, the thing to take note is here, aspect-oriented design and functional programming. These are different paradigms that kind of live alongside of object-oriented programming. These aren't design patterns. These are other ways of thinking about programming.
So, one of the ways that we try and make things suck less is that, well, we take all the time that we took building Cake PHP, well, at least our cumulative time together, which is a high adoption framework. Lots of people use it in the world. It's evolved over time. There are certain decisions that were made that suddenly 3 or 4 years later don't seem they now appear to be less than ideal, which is normal. Things progress, things change, and you discover that what you thought was the best solution when you implemented it 2 or 3 years down the road, it no longer is.
We also have included team members from other PHP frameworks, as well as other luminaries from the PHP community. All of these people have their input brought to bear on trying to make this framework better for everyone.
And yeah, don't get us wrong. We keep saying that frameworks suck, but the other frameworks out there, the major frameworks, they're the people who work on them. We are acquaintances, co-workers, and friends of most of them. Smart people doing great work, and there's some great stuff in all of them. Zen framework has some fantastic parts. Symfony has fantastic parts. Cake has fantastic parts. Kohana, all of these frameworks have great parts to them. So we're really trying to draw on the experience of a collective PHP framework community and try and find the sweet spot that combines all the best parts, at least the parts that we consider the best from all of these different frameworks. And we slap on the fact that we're going to do PHP 5.3 only and up. There's pretty much no way that you could port Lithium to 5.2. There are so many concepts that are just very central to the architecture and design that completely depend upon 5.3 features, which was nice because we didn't have to worry about backwards compatibility support and maintaining basically 2 different APIs. And we try to assume that the developer is a developer and that the developer knows how the language works, knows how PHP works, and is basically a good programmer. So we don't try and dumb down APIs or hide things from you. If we can expose some of the underlying functionality, then we try, so that you have the full flexibility if you do need it.
So we have one question from the audience, which is: do other people involved in other frameworks contribute to Lithium? Well, there are no other major people who are currently working on other frameworks also working on Lithium, but for example, one of the people on our core team is Will Sinclair, who is the former project manager for Zen Framework. Another good friend of ours, Mitch Pirtle, is the founder of the Joomla project, who's been working with us on improving Lithium as well. We also have people using Lithium like Sean Coates and Andres Mievsky and Chris Shiflett, who are all giving us feedback on how to improve it and make it better. So a lot of people are just contributing thoughts and ideas on how to help us suck less.
Yeah, and our channel is actually, our IFC channel is actually a really fun place to be. There's a lot of smart people that tend to hang around there. Some of them don't even use Lithium. They really just want to hang around and talk about development or ideas and best practices, and we completely welcome it. Yes, it is a Lithium channel, but we're all developers, and we're all cognizant. Wow, my English isn't very good today. We're all aware that the smart developer is one who's going to choose the best tool for the job.
And at the end of the day, we're all just trying to get our job done. So here's a couple of different ways in which we suck less. One is consistency. Now, I'm kind of a hard ass about consistency. So I spend a lot of time making sure every piece of code that's committed is gone over very meticulously to ensure that it's consistent with everything else. We feel that what is it?
Conceptual integrity.
Conceptual integrity. Thank you. Is of very, very high importance. So here's just a quick rundown of the anatomy of a typical lithium class in a few different parts. First is the constructor. You'll notice that in lithium, every constructor is exactly the same. It always takes exactly one parameter, and that parameter is always an array. So in this way, configuring instantiated classes is really, really simple. Secondly, the constructor, by default, calls this underscore init method, and this makes it really easy to take like high overhead operations or other harder test code and move it out of the constructor and into another initialization function. So, for example, you can do this to disable the default initialization. And third, we have the namespace. PHP 5.3 allows us to use namespaces, which gives Lithium a really easy way to map classes to files and vice versa. So in every single case, the namespace and class name exactly match the class path and file name from the base of the library or application. And then we have right below the namespace the list of static dependencies that the class has. These are usually like low-level utility classes or various other classes that you're never really going to want to switch out. And those are declared up at the top, so then you can just reference them by class name later on, and you can look at all the dependencies of a class just by looking at that block at the top. Next, we have any dynamic dependencies. This is kind of Lithium's concept of dependency injection, where you can say, okay, for the cache class, I want to use this fully qualified namespace name, and then below in the init method, you can use that cache class and call methods on it, do whatever you want. And then you're actually able to swap those out on a per instance basis just by passing a different cache class into the cache key in the classes array. And you can pass that into an object constructor, and it gets automatically populated in the class properties. Next, we have options. Any method in the framework that supports several parameters usually has an options array. Options is always the very last parameter in a method, and it's always an array. And it always takes key value pairs that indicate other parameters. This keeps parameter lists really short, makes APIs easy to extend, and is generally a good idea for clean code because you can see explicitly what the names and values of parameters are. And this is really useful, especially since PHP has no named parameter support. And config, we saw before in the constructor, exact same idea, except it modifies the state of a class or object. Whereas options is kind of a convention to say, okay, this is a referentially transparent data that you're passing into the method. It's only going to modify the scope of that method call. Config actually makes a change to a class itself or to some other class. We also delineate between configuration state and request state. So any classes that you want to set up or configure, that's all done in the bootstrap process, and then you don't change those. Most of those classes are extend this base class that we have called adaptable. And that's extended by all these classes in the framework to give you a way to configure them very consistently. And that looks like this. So for the authentication, for example, you tell it what adapter to use, any other configuration. And every configuration starts with a name. So you can see here in cache, we have 3 different caching configurations, one named local, one distributed, and one called default. Again, each one of them has an adapter to use and some other configuration. Same with database connections. You can define many different database connections of different types. MySQL, MongoDB, we also support CouchDB, and so on. Session, again, same idea, it's all the same. So also you can do this. If you, for example, write your own custom adapter class, you can pass any key value pairs into that configuration that you want. And this works because of the universal constructor. All the configuration just gets passed into the adapter when it's instantiated. So what about multiple environments? For a lot of this stuff, you're going to want to do something different in production as opposed to development. So that's really easy. Again, at the top level, we have the name of the configuration, and then nested underneath of that, we have the name of the environment. So we just have a simple string that matches the name of the environment that you want to use. And when the environment is configured in the Bootstrap process, anytime that you access the cache or access a database or whatever has a varying configuration per environment, the cache or database class automatically switches the configuration to use. And this works identically for all adapters that Lithium supports that extend adaptable. So the most important thing to remember about this configuration that we're setting is immutability. You set it up once in the Bootstrap and you forget it, you don't touch it again. This is kind of one of those hallmark issues that goes along with dealing with state, like we talked about. If you have state that's never changing, it's much easier to debug.
So we're trying to be as fast as we possibly can in Lithium because performance is a big concern for a lot of people who use frameworks. Because one of the trade-offs that you make and that you knowingly make is that a framework is going to be slower than the hand-coded application done from scratch with raw SQL queries is going to be. So we always get questions on, are we fast? And we always need to remind people that performance is a trade-off between speed of development and large-scale applications generally don't use stock framework infrastructure, and that's a really good thing because frameworks try and solve a lot of problems that you might not have. And when you have a large-scale, highly traffic site or application, you actually don't need a good chunk of the framework to do what you need to do. And general purpose framework will never be as fast as hand-tuned code, and we're quite well aware of that. We would not try and argue the opposite. But it turns out that Lithium is pretty damn fast. We like to give people choices, so you can also use. We like to give people choices in terms of selecting their own classes to be used. If you don't like one of the adapters that we ship with, writing your own or extending that one that we do ship with, and with your overriding the methods that you don't like or the functionality you don't like is relatively easy to do. We also advocate the use of pickle extensions wherever appropriate and whenever possible because C is always going to be faster than PHP. And there's a large number of high-quality pickle extensions out there to do various things. To run Lithium as a default, you actually don't need any pickle extensions, but there are some adapters that are out there that do require it, such as the MongoDB one. There's also a Redis cache adapter that requires the Redis pickle extension. Actually, it's not in pickle, but it should be. We also have the ability to replace classes at runtime in large parts of the framework. So if you don't like the fact that we're using our request object, you can relatively easily swap out our request object and use your own. And we profile it at every step of the way. We've been using various different tools. I'm a big fan of XHProf just because it's a really simple graphical tool that will show you, well, it's a simple tool that will show you in kind of a table format which calls are most expensive in a request, and as well as Xdebug and cache grinds and whatnot. We're also very conscious of the fact that there are some high-quality libraries available outside of Lithium. Of course, we're a very new project, and we don't have the scope like Zen Framework does. So we wanted to make integration of these other libraries as simple as possible. Like, let's say you want to use an SMTP mail handler. Well, lithium doesn't ship with those. One, because there are very many there are a lot of those that have already been written that are of high quality and that can interoperate with lithium quite easily.
So here's actually an example of how you can use lithium to kind of not do what it does by default, and in order to make something fast. This is a feature that was added to the router recently. Suppose you have a particular type of request that you need to serve really, really fast. Let's say an API call that's made frequently and that you just need to do something really simple. Here what we're doing is saying, if the URL matches this frequent API call .json call, just for example, instead of doing the normal framework dispatch cycle, we actually want to just invoke this function that's attached here. And the function is going to take in the instance of the request after it's been processed, and it's just going to return a new response object directly. And we can set the type manually to application/JSON and just do a direct model call, convert it to JSON, and return it directly. And that's hot. Even though the default dispatch cycle for Lithium is highly optimized, this is a way to just bypass everything that you don't need and optimize even further.
If anyone's ever used micro frameworks, there's a lot of them. They're quite popular in the Ruby community. Things like Sinatra. So this is basically a very similar implementation to that, in that you can handle requests and You can handle requests and send out responses basically just by capturing routes and then processing the data that comes in.
So this is just one way in which the framework is very flexible and adaptable to your needs. Now we're going to look at a couple of other ways. But first, we're just going to go ahead and say that Lithium is the most flexible framework out there, and we think you're going to agree. First of all, based on the fact that, as we saw, most dependencies are actually dynamic and can be changed at runtime. So, for example, this, like we saw earlier, most class dependencies are just declared in an array, and each time you instantiate an object, you can give it its own custom dependencies on a case-by-case basis. But the main point of our flexibility and extensibility actually comes from this aspect-oriented filter system. And here we're just going to take a look at a quick example demonstrating how it works. Suppose you have a method like post find that just returns some data from a database, and now you want to log that. So you can actually wrap a logging filter around that post method, and so that filter gets called every time the actual method gets called. Now let's say you also want to add caching. Again, both completely transparent to the underlying method and the other filters attached. You can just continue to wrap more stuff around it. So now when that find method gets called, what's actually going to happen is this caching filter is going to get hit very first. And then that caching filter is going to return the value of calling the next filter. So it's actually going to go into the next filter like this, and then finally into the method, and then return back out through each filter. So this filter system gives you complete control over how most methods in the framework get called. So next time this method is called, let's say it'll hit the caching filter first because it's the outermost filter. The caching filter can look and say, oh, I already have a cache for this particular call. I'm just going to return directly. So I have complete control over how these methods are executing. And I can not only mess with the parameters going in, but I can also mess with the return value going out and just completely short-circuit the method if I don't want to have it called for whatever reason. This would be an example. So we have a question from the audience. How do you tell which is first? Basically, the innermost filter is the one that's applied first, and the outermost is the one that's applied last. And the outermost is also the one that's going to be invoked first and return last.
So if you wanted to have caching but still log, then you would have log as the outermost filter, and then it would traverse into the cache, and the cache would then return.
We also had a question previously about how many classes load on the default or the micro routing syntax. I want to say it's less than 24. I mean, depending on, suppose you're not doing any other logic in the route itself. Yeah, there's maybe 20 classes that get loaded, and those are basic utility classes and
basically the core package, the util package, and the action package.
Yeah, actually, there are some classes in action that are required, as in the PHP statement require, inside of your Bootstrap, and that's basically just so they don't get auto-loaded. It's for performance reasons. So if you're designing your entire application using those micro routes, you could actually rip some of those out and maybe cut the total class load, at least for the core framework itself, down to maybe a dozen classes. So really not that many. And as far as how it compares, we had another question about how the lightweight version of the framework compares to other frameworks. I don't know.
Well, yeah, I mean, it's hard to compare because I have yet to see another framework that does this, another general purpose framework that does this. There are some micro PHP frameworks that implement basically just this syntax. We allow you to do both, and we also allow you to do basically as much or as little as you want inside the micro syntax, thanks to auto-loading on our library locator. It's going to be faster, obviously, because you're skipping a lot of the controller. You basically don't have a controller anymore. And if you're returning a response or a view directly in there, you're also skipping a lot of the intermediate classes that are done.
And light and heavy are kind of subjective terms, but in terms of pure requests per second, well, let's just say it is extremely fast. We have one other question. Is Lithium the only framework right now that is using aspect-oriented programming concepts? In PHP, yes. There are some kind of fringe projects that implement it in a much more kind of clumsy and unintuitive way.
Which to their to come to their side, it was several years ago where this was tried, where 5.3 didn't exist.
Right.
So very many different solutions with run kit or class kit, preprocessors that are written in C and whatnot.
Right, but nobody else is really doing this kind of aspect-oriented design. The concept, the general concept, was actually derived from, well, not derived from, but originated in the Java community. It was one of the very good ideas that they had, but they implemented it using a bytecode preprocessor that would actually hook into the Java virtual machine runtime and actually embed bytecodes before and after particular method calls.
Something we can't do.
Something we can't do without very hacky and frowned upon PHP extensions. So just to give you a really quick and simple rundown of how this works, here is a filter that does logging. So here we're saying, okay, we're going to apply a filter to the find method, and this is code that would normally run in the Bootstrap. So when the framework first starts up, this filter would be applied to the post class, and it would say, okay, every time the find method is called, invoke this filter first. So the first couple lines of the filter generate a message that's just an exported version of whatever conditions are being run. The logger write line there actually connects the two, connects the logger class to the post class and causes that to be invoked. And finally, the very last line is this goofy thing, chain next. Basically, the chain object holds all the filters that are being executed, and the very last filter is the actual method. So every time you call chain next and then return the value, that invokes the next filter in the chain. So visually, it looks something like this, where the filter in the blue there in the middle is actually connecting these two classes. And the takeaway is that those two classes know nothing about each other. They're completely disconnected. They're only bound together through this separate filter that exists somewhere completely different. So the great part about this is you could A, not only just rip out this filter without affecting the behavior of any of those two classes, but B, you can also take your entire logging configuration for your entire application and put it in one place instead of scattered throughout your application code. Same with caching or security, authorization, authentication, that kind of thing. So it's completely seamless to the rest of your app, and it's a very helpful way to organize your code. So what about competing patterns like observer? Well, event observers, one of the drawbacks is that they're dependent on a centralized publish-subscribe system. So that has, you can implement that in one of two ways. Either a global registry that creates mutable global state, which we learned previously is very detrimental to trying to debug, especially something as dynamic as an event system. Or you have another class that you have to pass around, or another object instance that you have to pass around everywhere you want to use this event system. And that just becomes cumbersome. Also, events create an extra layer of abstraction on top of the actual classes and methods that you're integrating. So you saw here in the code example, we're actually applying the filter directly to a particular method of a particular class. We don't have this abstract idea of an event that exists kind of disconnected from those methods or classes. There's also fewer possibilities. Like you saw with filters, we have complete control over the method that's being executed. We can cause it not to be called at all, or return some modified version of the return value, or modify the parameters that are going into it. Well, with event observers, you either have to tack that functionality on yourself, or just kind of deal with the fact that the communication is only one way. Like the post class might broadcast that this find event is happening, but the logger class, or say a cache class would be a better example, isn't able to actually intercept that and do something else with it that's not the default. Whereas filters are completely self-contained and attached directly to the objects that they're applied to. So there's no global state. And it's also, the syntax is very intuitive. So instead of inventing some micro language to set return values or modify things in an event system, you're just able to use the return statement directly.
One thing that Lithium tries to do is give you flexibility, and one of the ways that we try and do this is to use adapters. So many parts of Lithium have been coded in a way that we have an adapter-based framework. So databases, we've got those as many different adapters. We've got first-class support for document-oriented databases like MongoDB, CouchDB. We've got relational databases which are in beta, being improved upon gradually and quite progressively. We've got one that works for Cassandra as well too, which we'll end up releasing at one point. And everything is, and when you have a request, this isn't even my slide.
Oh, sorry. Yeah, so the thing that we wanted to point out here is that this syntax that works across all of these different data stores. So you can create a new type of object of whatever model you're building. It creates the same type of object that conforms to the same API. You can save it, you can reload it, and all the properties or all the fields in your record or document or column store or whatever are just accessible as object properties. So it's really simple. This is the default API that we provide. You can also build more abstractions around it so that your models aren't tightly coupled to your data, but we just offer this as the basic API because it's simple and straightforward. So this syntax works pretty much identically on MongoDB, CouchDB, MySQL, and now actually we have SQLite fully functional and Cassandra as well. So on But we don't do that at the expense of, say, sacrificing functionality on other databases. So here, for example, you can see we're actually storing arrays and sub-objects. So the tag object, or the tag field rather, is actually a PHP array, and MongoDB and CouchDB can store that array in its native form. Also, the author field is actually a sub-object that can contain, say, any other vital statistics about the author, and you can save that directly to Mongo or Couch and reload it, and it turns back into native PHP values. MongoDB even supports even more features than CouchDB. For example, you can query based on an array of tags, and that translates to a native MongoDB query. And you can also query on sub-objects. So the author, the name field of the author sub-object, you can actually query directly on that in Lithium, and it gets translated to a native MongoDB query. So in addition to having everything based on different adapters that are all completely pluggable and loadable from custom plugins, we'll also ship with fully compliant MySQL and SQLite adapters that are fully compliant with all of our native APIs. We also have a SQL Server plugin in the works that will work with this as well. And underlying all this, we actually have the Query API, which kind of sits between the models and the database backends and makes everything work.
So the Query API is actually something relatively simple as a concept, but gives us a lot of flexibility. It's really just a data container that contains all the different keys and all the different operations that a query can try and do, such as the fields that it's operating on. If it's a relational database, the joins that it's trying to achieve, the joins that are trying to be done on it, conditions, limit, skip. And it allows this object basically allows us to have each backend only worry about these options that it wants to implement and wants to care about. And it lets us separate the API from models, so the find APIs, completely separate from the backend database, from the backend adapters.
So that allows you to have some really flexible custom queries. So for example, this is a grouping query that you can run in MongoDB. And it's a completely arbitrary query, and it supports MongoDB-specific features that no other database has, and you can just pass those directly in. If your model's database backend is MongoDB, it will just work. So here's an example of actually instantiating a query manually. And suppose I had an SQL relational database, and I wanted to query some posts based on tags. So here what I'm doing is saying, I want to find all the posts where the ID matches a subquery where I'm finding all the tags that match foobar or baz. So if you want to set up your own kind of way of interacting with backend databases, you can do that through these query objects and actually not use models at all. You can use your own custom classes. So you can run simple queries directly through the model API, or since no ORM will ever be both abstract enough and efficient enough for all cases, you can actually just build your own queries directly with the Query API. Another thing that the database layer allows you to do is actually drop in an intermediary layer for, suppose you wanted to take those query objects and generate custom optimized SQL for particular cases. You can do that too. In addition, we have a plugin called Li3 Doctrine that integrates the Doctrine 2 object relational mapping system directly into Lithium, so you can use that for your model backends as well.
it basically gives you the fact that you can use the Lithium Query API, not the Lithium Query API, the Lithium Model API that you know and are familiar with, but have the full power of Doctrine on the back end, which is also a really fantastic object relational mapper that it really is quite awesome in its 2.0 version.
So in addition to Doctrine, we actually have really tight integration, or working on some tight integration with other frameworks as well. Any framework that uses the PSR0 loading standard?
Yeah, any framework that uses this PSR0 loading standard, which was basically evolved by several of the major frameworks and major projects, that indicates how classes should be named, how folder hierarchies should be named as well. That basically allows all these people to implement a common autoloader, so that loading a class from Lithium is actually the same the same way that you load a class from Zen Framework 2.0, the same as Symfony 2.0, the same as Doctrine 2.0.
So Lithium was actually the first framework to implement this fully, and since then Symfony 2 is implemented, and now Zen Framework will be implementing it for their 2.0 version as well.
And for those who have not implemented the common autoloader, we also provide methods when loading the libraries to make it so that the loader can know where these classes are. So here are just two examples. They're a little bit verbose, but they allow you to load classes from Zen and the Zen incubator as if they were native to Lithium itself. And then you end up using them just like this simply. So the use /Zen mail storage pop3, and then create an instance of it directly inside of your code.
We're also working with the Solar framework, because that's another very, very high quality project that has implemented a lot of classes that we have no intention of implementing, such as mail.
Yeah, if I ever have to read another SMTP RFC, I think I'm going to shoot myself.
So yeah, that's just another one of the ways in which Lithium leverages other frameworks and class libraries and makes them very easy to use in Lithium itself.
So this has been a presentation by Nate Abeli and Joel Perab. Lithium, you can check it out at lithify.me. Like we keep saying, it sucks, but you should try and check it out anyways. And thanks for sticking through with the presentation, even though it's not the best quality in terms of color for the video output, and the fact that we're both completely exhausted and I can barely speak English at this point.
So now we'll be taking a couple of questions from earlier in the presentation as well as right now from our audience. So one question from just now, will we be able to plug in Solar's classes without worry, just plug and play? Yes. Solar's classes actually are very similar in design to Lithium's classes. Solar was actually the first framework to implement the universal constructor, and that's where we actually got the idea from. So it's very easy to configure and use Solar classes along with Lithium. And Solar classes use the pair autoloading standard, which works for PHP 5 below 5.3. So it's very easy to write an autoload mapper that works more or less the same as Lithium's native one does.
I mean, we're working on projects that use classes from Pair, that use classes from Zen Framework for some of the various tasks that the application needs to do. And really it was just a matter of configuring the loader, which ends up being those snippets that you saw. And as soon as that's done, using classes from Zen Framework or from Pair or from any of these other major frameworks is really, it takes absolutely no effort at all. It's quite simple to do.
So another question that we got earlier in the presentation was about configuring database clusters or using different databases for reading or writing, or say reading from slaves and writing to masters and that kind of thing. That is something that you could configure through the connections class like we saw earlier. There aren't any database adapters that handle that natively, although MongoDB handles that at a different level where you can connect to one IP and it will kind of proxy all your calls to a cluster for you. For other databases, though, you would probably configure it, I suppose, using a filter that would change out, would intercept calls at the database level and change out which connection to use, or just implement a proxy class that takes all of your database connections and switches out which one to use based on the method call. And those are all very easy things to do.
Right, like using a filter to be able to do that is relatively simple. You'd write two filters, one for the find calls and one for the save calls, if you want to have, let's say, a master-slave setup, so that on all find calls you make sure that the connection is set to your read slave, and on all the save calls that all the models perform, they end up going to your write master. And if you want something like a very distributed sharded setup where you know that certain requests are going to be going to certain servers, that's also doable in a filter. With complexity or whatnot, I'd probably recommend a proxy class like Nate was describing, simply because you can do it in a much more organized and programmatic way.
Yeah, so if you had, say, like a round-robin cluster of servers and you just wanted to kind of pick one arbitrarily for each request, you could implement a proxy class in not too many lines of code.
Right, like if you had MySQL with 4 read slaves for some reason, because you're very read-heavy, that would probably be the best option.
So another question that we got is, compared to, say, Cake, for example, will you be able to have more options to use, whereas the vendors thing was a little awkward? So in Lithium, everything is a library. The Lithium core itself is a library, your application is a library, plugins, other vendor libraries, they're all handled in exactly the same way. So you define a configuration, usually just a name. As long as they're in the correct directory, all you have to do is specify the name, and in some cases, let's say if they're using pair, old school PHP 5.2 and below loading rules, you have to specify a closure to rewrite the rules, like we saw in the previous example. Other than that, there are no other conventions. Everything is exactly the same. So one of the questions we have is about testing suites and profiling. Lithium has its own test suite that we ship with the framework. It's very, very fast. And
so we do get some questions sometimes relating to the test suite, and the question is always like, well, why aren't you guys using PHP Unit? PHP Unit is a fantastic testing framework. I mean, it's hard to compete against people like Sebastian Bergman and whatnot at writing a testing framework. But we felt that we could try and leverage some of PHP 5.3's new features to write something that is a bit different and that suits our purposes for testing. As a result, we've got a framework which is quite fast to run through tests. We can run the 5,000 or so tests in Lithium in less than 30 seconds quite easily. And a fair amount of those are actually, let's say, database calls, so those are going to be the same length in any testing framework. Mm-hmm. And some of those are actually sleep calls as well that are for testing the cache. So we're quite happy with what we've got. Our testing framework isn't perfect. We're always looking to improve upon it and make it better. But like I like to say, if no one ever tried to reinvent the wheel, then we'd still be riding ox carts. So we're happy with what we've got. We're trying to make it better. We know that it isn't as high quality and as fully feature complete as something like PHP Unit. But we're working towards making it better every day.
As with most other things in the framework, it's light and fast and is exactly what we need. If we needed something more full-featured for, say, a particular application, then we would just switch to PHP Unit. It's quite easy to write Lithium tests or tests for a Lithium application using the PHP Unit test suite. So
right, there's nothing stopping you from writing your application and using PHP Unit to write your test for your application.
On profiling, we actually, as Joel mentioned earlier, use XHprof on a fairly regular basis. We test about once per release cycle. The
There's a filter actually in a blog post that was posted, maybe 0.7 or 0.8, the release announcement. We posted a filter that we use to basically invoke xhprof and wrap the dispatcher run call, which basically allows us to profile 95% of the loading sequence. Of the dispatch cycle. And it's relatively easy to use. Once you have xhprof installed, getting the filter to run is really just a matter of like placing it and making sure that the paths are correct.
And as far as how Lithium stacks up to other frameworks, I guess we could just say it's quite fast. Solar is noted as being one of the fastest PHP frameworks around, and we are within a few requests per second of their default Hello World system.
And this is us without having done really any kind of like micro optimizations or whatnot. I mean, we profile with xhprof to make sure that we're not doing something completely stupid that's going to slow things down. But we haven't really started profiling with the intent of, well, let's try and make this as fast as humanly possible. So we're quite fast without really trying too hard.
Yeah, and one of the slowest parts of any of our dispatch cycle is the routing, because our routing system is completely dynamic, and pre-calculating those routes is a very expensive process. However, that's easily cached. It's just, again, something we haven't implemented yet. It's easy to do, but just because we haven't really had an urgent need to do it, we simply haven't done it yet.
Right, and dynamic routing is pretty much the heaviest thing in any framework. You can do a lot of tricks. I know Symfony had a really neat trick that they released a while back, and that they actually will take your routes file that's written in PHP, parse it, and turn it into an htaccess file, which then turns your application level routes into web server level routing, which is really clever and quite well done, because that saves a huge amount of time, because then the routing is done at the web server level.
So yeah, that's about it for that. Any other questions?
All right then. Well, you guys can keep posting questions in the channel or the Li3 channel. We'll be happy to answer them in a more text-oriented format. But thanks for sticking through this. I'm happy to have done this and taken some time to meet some new people, new names that I see in the channel.
As am I. So thanks, guys, for stopping by and asking us questions and following along with us. Oh, we have one last question. Sorry about that.
Okay.
So our final question that we're going to be taking is discussing transitioning from cake to lithium. I guess I would say, in kind of summary, that a lot of the concepts are very simple, or similar rather. The organizational conventions, we have controllers and models directories and that kind of thing, and we have an index.php and a bootstrap.php. So that should all be very familiar to any cake developer.
I mean, so Cake has a lot of really good parts to it. We tried to take the best parts of Cake and do something similar in Lithium. So when you're developing an application in Lithium, you obviously have to use a Lithium framework, which has come up with different things. We now have separate objects for request, for response. We have a media class that brokers all the different media types and determines how to interact with the response objects and whatnot. So there are different levels of complexity that have been added. But in general, with, let's say, your standard typical Hello World blog example, writing in Lithium, writing in Cake PHP is quite similar.
Yeah, in fact, a lot of that will actually be almost exactly the same. The organizations for models, controllers, and views are almost all identical. The only difference you might notice is that, for example, where Cake templates end in, like, say, views/controller name/action.ctp, where lithium is views/controller name/action.html.php.
Which is nice because now you don't have to futz with your editor to get syntax highlighting in the PHP files. Small victory.
Indeed. And the other really interesting thing to note about Lithium is that because it uses namespaces, you can actually run Cake PHP inside Lithium and vice versa. So if you have one particular part of your Cake app that you want to use MongoDB for, and you want to use Lithium's models to interact with your MongoDB application, you can totally do that. And just by loading, there's a tutorial on the website for loading Lithium into non-Lithium projects. And it's really, really simple. So that's an option as well, if you just want to kind of get your feet wet with an existing Cake app.
Right, if you wanted to develop some new feature, if you wanted to do something a little bit different and try Lithium inside an existing app, then it's actually not too difficult. Obviously, you know, you're at that point you're integrating two different frameworks, and you're adding a little bit more weight to everything. But why not try it out?
The other thing to note is that part of what enables this is the fact that everything in Lithium core is organized into packages. We have, I think, a little over a dozen packages, and there are only two required. One is called core, the other one is called util, and that is basically the micro core of the Lithium framework. And from there, just depending on those two packages, you can load up almost any other package in the Lithium core without dependencies on any of the other 10 or so packages that you're not using.
Right, you could pretty much extract the core package and the util package, which gives you the filter system, the aspect-oriented filter system. It gives you the library locator and a bunch of utility library locator, a bunch of the utility libraries like the validation, string class for string substitutions and hashing and whatnot. And you could build your own framework out of that because those two packages only depend upon each other.
Okay, one last question. Will there be a robust console tool to generate code like Cake's Bake? There actually already is. We have it's actually even more extensive because it leverages not only template files, and you can easily plug in your own template files in your app or plugins or whatever, but you can also generate entire applications. We've leveraged PHP 5.3's FAR capabilities, where you can actually package entire applications up and have Lithium generate new applications off of your custom templates. So I think at this point we're going to wrap up. Thanks again, everybody, for watching, and have a good night.
Feel free to post questions in the channel and wherever in our channel. Ping us on Twitter. We're around digitally quite often, so. All right, thanks everybody.